Ladies and gentlemen, I would like to welcome you to the last session of the Digital Transformation in Government Conference. And we are very fortunate today to have with us uh, Dr. Vik Pant, Chief Scientist and Chief Science Advisor for Natural Resources Canada, more affectionately known as NRCan, because I know we have a lot of people from over the globe. And so if you hear NRCan, it's Natural Resources Canada. He's going to be talking about science and policy integration, the NRCan Digital Accelerator, and Technology Readiness Assessment. Uh, Now, Vik is responsible for providing strategic direction to build capacity within our NRCan scientific community. It's creating a departmental vision for the science and technology and assessment of future needs. It involves leadership in developing and advancing priorities, providing strategic policy advice on horizontal science issues, and opportunities to ensure strong linkages between science and policy communities, and promoting effective engagement of science and technology activities. He's responsible for accelerating the creative application of innovative digital technologies, including artificial intelligence, to enhance NRCan's ability to conduct research and analysis, as well as provide evidence-based policy advice that is supported by advanced analytical techniques. Vik works with his counterparts from other science-based organizations to ensure that the management of federal policy and research activities support and align with the Government of Canada's priorities. Vik earned a doctorate from the Faculty of Information, the iSchool at the University of Toronto, a master's degree in business administration with distinction from the University of London, and a master's degree in information technology from Harvard University, where he received the Dean's List Academic Achievement Award. His research, featured in numerous peer-reviewed journals and refereed international conferences, focuses on the conceptual modeling of strategic co-opetition in complex multi-agent systems. He joined NRCan from the Mars Discovery District, a technology startup accelerator in Toronto, where he was a senior technical advisor of applied artificial intelligence. Prior to that, he held progressively strategic positions in leading software enterprises, including Oracle, SAP, and OpenText. Without further ado, over to you, Vik. Delighted to have you, and thank you very much for coming.
Thank you. Thank you very much, Bob. It's my pleasure to be here today. And also thanks to Jean-Luc for helping us get together on this virtual platform, and very honored to join this distinguished panel of presenters. I had the opportunity to look at the website and very, very impressed to look at the list of colleagues from across the Government of Canada, indeed all over the world, that are sharing their insights in this conference. So I'm very happy to talk today about the Natural Resources Canada Digital Accelerator, which is a strategic initiative that is really helping our department to take advantage of all that emerging and emerged technologies have to offer in the pursuit of advancing science and policy integration. So I'd like to start by talking a little bit about Natural Resources Canada. Natural Resources Canada is a federal department in the Government of Canada, and the focus of our department is to improve the quality of life for Canadians by ensuring that our country's abundant natural resources are developed sustainably, competitively, and inclusively. And even if folks have not sometimes heard about Natural Resources Canada, a part of the NRCan family are organizations that I'm sure most people have heard about. For instance, a Geological Survey of Canada, the Canadian Forest Service, Canadian Centre for Mapping and Earth Observations are amongst the world's top scientific institutes and organizations in their respective fields, and they are all a part of the NRCan family. And in fact, some of the examples I'm going to use today to showcase, once you know sort of what the NRCan family looks like, I think it really helps to situate and ground and contextualize where some of those examples are coming from. But before I go into the examples and start talking about some concrete applications of artificial intelligence, data science, machine learning, and those kinds of technologies, I want to take a bit of a step back and talk about, for instance, the importance of digital solutions at NRCan in a broad frame. We are a science-based economic department, so the outputs of our science inform our policy, and it's our policy priorities then help to orient and to tune our science with a view to the future. Now, how we go from the science knowledge to policy insights is using these advanced digital solutions. So in fact, you can think about some of the things I'll talk about today, these digital solutions, as the bridge between the world of science and the world of policy. And this is really something that the Digital Accelerator, which I'll introduce to you, is something that is fine-tuned and focused on achieving for our department. So about 18 or 20 months ago, we launched in NRCan our Digital Accelerator. And you can think about the Digital Accelerator as a center of excellence. And in this center of excellence, we recruited top talent data scientists, digital solutions architects, software engineers from outside and inside the government. And our accelerator has 4 goals. The first goal is the creative application of innovative technologies to advance science and policy integration. So you can think about doing projects. You can imagine that we have science experts in our department. We have policy leaders in our department. They have lots of data. They have a deep domain understanding of their respective fields. They are experts. They are subject matter specialists in their areas. And they are interested to leverage the promise of what this technology around AI, machine learning, deep learning, etc., have to offer. So through proposals, they contact our Digital Accelerator. And in our Digital Accelerator, we have data scientists, we have digital solutions architects who are experts in the field of applying AI. So what we do is we take a look at the proposals. We have a process by which we evaluate these proposals. And once we accept a project, we co-produce value. It's not a turnkey model where we take the requirements and then we sort of do all the work in some corner and we give back the finished products to the proponents of the projects. What we do is when a project gets approved, the team from my Digital Accelerator works closely with the proponents, whether they're policy leaders or they're science experts, to really co-create some innovative applications of these promising technologies so that the proponent can achieve the goals that they want to achieve, whether it be in the case of science, whether it be in the case of policy, or more likely at the intersection of both. So that's one of the things which we do for our department, is that we deliver projects using these avant-garde technologies that can really help to solve problems in new ways or help to solve problems that were not solvable before. The other thing that's very, very important for us is really this notion of promoting a digital-driven culture. And what that means is that very often when we think about accelerating digital transformation of enterprises, what ends up happening is that groups of experts become siloed. So you have some experts who have deep domain knowledge or subject matter expertise when it comes to some technology area, such as AI. But then what happens is that they are the only ones who really know that. So if you don't have proper mechanisms, if you have not forethought how to raise the collective digital acumen of your enterprise as a whole, how to elevate the collective digital quotient of your department or agency as a whole, then yes, you can do a lot of successful projects, but in terms of the diffusion and the proliferation of knowledge throughout the enterprise as it relates to these important technologies, it doesn't really quite work as well. So that was something we did not want to sort of fall into the trap. We wanted to make sure that everything was done in a way that could benefit as appropriate colleagues throughout our enterprise, and indeed in many cases throughout the government of Canada. The third piece that we wanted to really focus on was some of the problems that we are solving require the use of very advanced techniques or very sophisticated software, which only a few people in the world might know. And so we wanted to recognize the importance of value constellations or value ecosystems, whereby we could have our experts on the domain side, whether it's science or policy, as well as on the digital side. But we also wanted to be able to tap into the broader tapestry of competencies and capabilities in Canada and in the world more broadly, so that we could create win-win value propositions, not just for us, but also for any partners that wish to join forces with us on these projects of meaningful impact. And this is one of my motivations for presenting this talk, is if you hear anything in this presentation today and you feel that you'd like to partner with us, or that there's some complementarity or synergy that you'd like to ally with us, please do contact us. And I have the contact information for our accelerator at the end of the presentation. And then the last thing that I want to also focus on quickly is that when we set up the accelerator, the one thing we also wanted to make sure was that in government, we want to ensure that there's proper governance. So there are proper committees, there are proper workflows, there are proper routing mechanisms, there's proper systems by which work gets done in government. And we wanted to make sure that even though we're exploring and experimenting and moving fast and trying a lot of new technologies very, very quickly, that we abide by and comply with and comport with all of the rules and regulations that exist in our department to ensure that there is trust and there's credibility in the work that we're doing, and so that our decisions decision rationales can be inspected as required by our colleagues in audit and evaluation, and our colleagues more generally. So these were really the four main guiding principles of when we started the accelerator. The first was creative applications of innovative technologies to to advance science and policy integration, ensuring that we collectively, the second was collectively uplift the digital quotient and the digital acumen of our department. The third was that, as I always like to say, nobody knows everything and everybody knows something. So how do we partner and build these synergetic value constellations or these complementary value ecosystems with partners from inside and outside the public sector and inside and outside Canada more broadly? And also, how do we do all of this in a way that respects and abides by the rules and regulations by which government administration is conducted? So having said that, I want to give you a little bit of a vignette of some of the projects that our accelerator has been doing. But at a high level, happy to report that, as you can imagine, when we are NRCan and we focus on the themes of energy and forestry and mining, you can understand that some of these are fairly self-apparent, self-evident applications of data science to solve science and policy problems. So if you think about predicting the spread of groundwater and floodwater, that's something our colleagues do very regularly in the Canadian Centre for Mapping and Earth Observation, as well as in the Geological Survey of Canada. When you think about estimating the spread of wildfires and forest fires, as well as approximating the infestation of invasive species and pestilences, this is some groundbreaking work that our colleagues in the Canadian Forest Service do. And also, when you think about smart prospecting and just making sure that there is no or very little ecological impact when we do energy prospecting, or even when we plan for renewable sources of energy, that indeed that we can model energy yields using artificial intelligence and advanced predictive techniques. So at a high level, these are some of kind of the areas where our team works with our, as I mentioned, policy leaders, as well as with our science experts. But today, I'm going to walk you through some more concrete examples of the types of projects that our team has either completed or is currently working on. So very, very exciting stuff going on. Now, what's interesting is, in the mainstream nowadays, and sort of in the zeitgeist, if you will, everybody talks about machine learning, deep learning, reinforcement learning. It's really quite, it's everywhere. Everybody talks about applied AI. And indeed, I mean, organizations are adopting it. Our smart devices in our homes, on our person, they're all somehow impacted by and feeding into the overall AI story. But within Natural Resources Canada and within our sort of NRCan family, this is not something that's very new. For instance, I'm going to point you to a few papers that were written by Canadian Forest Service scientists back in the mid-1990s, almost 25 years ago, using advanced techniques of the day to solve problems of prediction, to solve problems of simulation, to solve problems of forecasting, classification, regression, those types of things. So these are very interesting problems where folks were taking a look at aerial photography and applying different types of data mining techniques back then, or some kind of data inspection techniques to be able to to infer relationships in those data. Now, this is going way before machine learning and deep learning and these kinds of technologies became very, very mainstream. These are some papers, again, by CFS scientists, Forest Service scientists back 25 years ago, applying the best techniques of the day on time series data or sequential data to find relationships over time and through time between independent and dependent variables. If you look, for instance, with the Geological Survey, again, same kind of time frame. And here they're talking about a neural network approach for geological mapping. Now, this is not deep learning, this is shallow learning. But nonetheless, I mean, given the data sets which were available in the day, given the types of computational hardware that was available in the day, and the best algorithms and optimization techniques and architectures which were available, this was really groundbreaking work. And since then, so going back 25 years to today, things haven't really slowed down for us. And if anything, not only have our scientists been making contributions in their field of expertise, where they're applying these groundbreaking technologies to create new insights, but indeed, they're also making contributions into the field of artificial intelligence and data science more indirectly by showing some of the practical applications of these techniques and technologies that seem to be evolving and rapidly transforming the landscape of the art of what's possible using applied artificial intelligence in science and in policy scenarios. So it's against that backdrop that you can imagine that an organization such as our Digital Accelerator can even function. Because if we're trying to apply the latest and greatest developments in the world of theoretical artificial intelligence or conceptual breakthroughs in artificial intelligence and bringing them and grounding them to real world problems and ensuring that they can make a meaningful impact. It's not good enough to just have data scientists who know how to write the code and to train the models. You also need absorptive capacity on the part of your scientists, on the part of your policy leaders who can appreciate the art of the possible and can meaningfully co-produce value propositions from those models that get trained. And as I mentioned before, this is why we set up our model in such a way that we don't have a kind of turnkey model where we get requirements and we go away and we train the models and come back and give them. No, it's that the proponents have to work with our data scientists and really share the domain knowledge from their side, and at the same time absorb the data science knowledge from our team side, and really in the big picture have something that can scale and sustain as a model, as a digital solution over time and through time. So this is something I wanted to give you a bit of a backdrop to the type of work that has been going on very successfully at NRCan before the Digital Accelerator ever came around. And now with the Digital Accelerator that I'm describing, it's something that we've been able to really elevate and take to the next level. So this is a good example of a very useful project that our team has been contributing to. This work was led by our colleagues from the Canada Centre for Mapping and Earth Observation. As I mentioned, they're a part of the NRCan family. And this project you can actually find on GitHub. So if you wish to contribute, if you wish to download the code base, if you wish to take a look at it yourself, you're most welcome to do so. You can use a search engine of your choice and search for Geodeep Learning. And sure enough, you can find it on GitHub, which is a open public repository where you can go and collaborate, crowdsource, and wisdom of the crowds collaborate on software development projects. Now with Geodeep Learning, as you can imagine, this is a very interesting project because you have satellite imagery or aerial photography, but more broadly satellite imagery coming in. And satellite imagery is generally raw pixels. So you have raw pixels arranged spatially. And if you are going to be analyzing them manually, or if you're going to be inspecting or interrogating those arrangements of raw pixels sort of on a human basis, it's not something that is very, very scalable, because the volume of information coming in is so fast and the quantity of data is so massive that having computational support to accelerate and to jumpstart and to turbocharge that process of analysis can really help you get a lot farther and have a much better return on investment from the assets in the sky, which are beaming down these raw pixels for your decision making or policy planning and things like that. So by training an ensemble, training a portfolio of artificial neural networks, which are calibrated for computer vision, or what's called machine vision, we are able to take satellite imagery as it comes off, run it through these models, and then down to the pixel level, you can do classification. So you can look at a pixel and say, is this the top of a tree? Is this the top of a water body? Is this the top of a road? Is this the top of something else? And then you can essentially classify the image. You can do semantic segmentation or instance segmentation. And you can now have this pixel level overlay of features which have been extracted from the raw pixels on your RGB imagery coming off the satellite. And now you can imagine that once you have that overlay, it can have all types of uses downrange. You can have all kinds of applications of it downstream, right? Because you can use it not just for the purposes that our colleagues in forestry, energy, and mining use, but you can also use it for all types of other purposes, such as emergency response, critical services planning, public safety. You can use it for planning purposes from an urban development perspective. So as you can imagine, this kind of an approach really not only helps NRCan to take advantage of the latest and greatest that technology has to offer in the field of machine vision or computational image inference, but at the same time, you can use the results of that in many other areas that are of interest to other government departments within Natural Resources Canada. So this is one of those very interesting projects where my team had the pleasure of collaborating and continuing to collaborate with our exceptional colleagues from the Center for Mapping and Earth Observation, and really co-create a value that is a win-win for us and for them and for everybody that comes into contact with this type of a system. So this is one example. Another very interesting project that our team has been working in very closely with our colleagues from our energy technology sector is to think about as Canada, like many countries in the world, more and more people are switching to cleaner automobiles, cleaner vehicles, zero emissions vehicles, especially electric vehicles. We all know that as we drive around nowadays in Canada, that there are more and more electric vehicle charging spots which are appearing to us, right? If you go back a couple of years, there were fewer of them. Now there's more, and certainly this number is increasing to grow. So that is one of the priorities of our department. And so where do we place these electric vehicle charging stations? Because as you can imagine, we certainly don't want to place them equidistant from coast to coast to coast, because that's not where they'll be used the most. So by building a high dimensional data cube or a hypercube, and then loading it with relevant information about, at a population level, certainly anonymized and de-identified, where it is that people that own electric vehicles live, where is it that people that typically own electric vehicles work, what kind of routes do they take, where are the electricity grids, where are the transformers, where are the the downstepping transformers, where you need to then take the energy from the grid and make it into a format, make it into a voltage level that your car can take, and things like that. So there's lots of things you have to consider before you build, if you will, a recommender engine, a geospatial recommender engine that can make sort of suggestions about here is where it would be a good spot and why, and here is where it would be a good spot and why, and things like that. So this is a current work in progress that my team is working very closely with our scientists from the ETS. Now, what's very interesting about this project is we've also partnered with Microsoft, because Microsoft has a commitment also to electrifying their fleet, and they're a large global organization with a lot of interesting data sets and some subject matter expertise in the topic around this type of modeling. So this really shows you how we are now thinking outside the box, solving problems which would otherwise have been quite difficult to solve without the types of tools and techniques available in modern AI packages. But we're not doing it alone. We're doing it in partnership with other federal departments. We're doing it in partnership also with world-leading technology firms such as Microsoft, to really create a better situation for deciding where these charging network spots need to go throughout Canada. So this is an interesting project as well that we are currently working on and making progress with. Another interesting project that we are working with is what's called the Energy Star automation project, or what we call the Energy Star Detective project. It's our team working in close concert with our colleagues from the low carbon energy sector within NRCan. And one of the things is, when you buy an appliance that has an Energy Star logo, as you see it on the screen right now, it gives you a peace of mind. As a consumer, it gives you the peace of mind that this appliance or device has gone through some rigorous testing. It has gone through some strenuous testing, and you can be confident in the knowledge that essentially when you use it, you're using a device that is environmentally consciously made. You understand how much electricity it consumes, you understand what type of benefit it gives you, so you're confident in knowing that it's not sort of an electricity hog or a power hog in any way, shape, or form. Now, unfortunately, what happens is that sometimes these logos get misused. And so there are organizations that or resellers, for example, who might just print a logo and put it on some device, or put a logo on their website on some device when that appliance is actually not Energy Star certified by the Energy Star authority. So what happens is that in that case, on a website, it's very, very difficult. I mean, just imagine all the e-commerce websites in Canada where you can buy some type of an appliance or some kind of an electricity device that has an Energy Star logo on it. If a human inspector was to go from one website to the next website to the next website to the next website, it'll simply not be feasible or viable to be able to keep track of where misuse of this logo may be happening. So one of the tools that my team is working on with our colleagues from the low carbon energy sector is to automate that process of surveillance and automate that process of monitoring to ensure that the integrity of this logo is preserved. Because certainly we want Canadians to have peace of mind that when they're buying an appliance or a device that portrays to be Energy Star compliant, that it indeed is. So by training this spider and crawler that can go out to e-commerce websites which are advertising or promoting, if you will, utilities or devices or sorry, appliances, I should say, that are Energy Star compliant, we can see them, and then we can cross-match them against the master list to see whether something that's advertised with a logo of Energy Star is actually truly an Energy Star certified appliance or not. And even when the logo is visible in the picture, then we can take a look at that logo and ensure to make sure that that logo complies with the latest version of the actual logo, which is currently supposed to be used by the manufacturers and the resellers. So as you can imagine, having this kind of an automated tool that can do that survey and then can come back with a list of potentially suspicious websites or web pages or catalog entries, then our officers can take a look at that in more detail and inspect that a bit more thoroughly, as opposed to clicking through individual websites and trying to navigate the catalogs of all these mega electronic warehouses, because that's certainly not something that is scalable or sustainable over time. So another very interesting project that combines fuzzy matching with computer vision and machine vision and things like that to really solve a problem that otherwise, from a scale perspective, would be quite untenable. This is a project too, which I'd like to highlight for you. So this is an interesting project that our team is working on with researchers and scientists from CanMet Energy, which is another part of NRCan. And here they have a device, a physical device in their laboratory, where they're able to inject certain types of materials, inject certain types of gases, and then on top of that, inject other particles of interest and be able to track those particles as they travel through space and time, to be able to make some inferences about, in this case, the construction of natural gas using limonite ore as the oxygen carrier. So essentially, it's something that our scientists in CanMet Energy like to use to be able to study the behavior of different types of gases and in different types of operating conditions, to look at energy efficiency and things like that. Now, the issue is with COVID, when it got difficult to go into the labs, one of the things that became very relevant was to build, if you will, a computational analog of a physical device. Because in the normal circumstances, you can go to the lab and you can fill that apparatus with whatever substance you want to test, and you can fire particles through it, and then through detectors on the device, you can trace the path of those particles on that substrate. But if you can't even get inside the lab because the lab is closed due to provincial health regulations, or for other reasons there are capacity constraints on how many people can be in the lab at the same time, then it really becomes useful to have access to some type of a computational analog or a computational representation of the physical instrument that you're trying to use. So yes, even if you can't access the physical instrument, perhaps you can actually use this computational analog of that physical instrument to be able to do some simulations, to be able to do some what if analysis. So here my team worked with the experts at CanMet Energy, who were running this project on some advanced computational fluid dynamics modeling, where they were able to take some actual real world training data out of this machine and train a machine learning model on top of that, so that now, even though it's not as good as perhaps, let's say, going into the physical lab to do these experiments, but when that's not possible, it's good to still be able to generate test results and to be able to do some type of sampling and do some type of analysis from a distance. So very interesting project that is going to be beneficial for designing better types of energy systems in the future related to clean heat and power. Another good example I want to use is colleagues from the Canadian Forest Service. So imagine what we talked about earlier, where we had satellite imagery and we were using machine learning on that satellite imagery to extract features, to assign class labels down to the pixel level. Now, if you think about how important the forest sector is to Canada and how important it is for us to keep track of our forest inventory, then that is something, as you can imagine, can be well supported by that type of satellite imagery. Now, it's not that the satellite imagery by itself will be a sufficient contributor to keeping track of the inventory. Of course, the inventory will require forestry scientists to go out and actually measure the health of the forest by being out in the forest and perhaps collecting some tree core samples and doing some studies in situ and doing other types of inference on the ground. But certainly having that macro view that you can actually use by having these satellite imagery with the semantic layer of what the pixels stand for on top overlaid. And now you can feed that into your larger information system that is giving you insights about your forest inventory, can really just elevate the quality of the inventory and can really help you to get a better idea of the scope, the span, the health, and the nature of your forests in Canada. So very, very interesting experiment, very interesting, I should say, application of artificial intelligence, which our data scientists are now combining forces with our domain scientists and policy leaders to answer questions, either using different methods or methods that weren't available before. And these are just a few of the examples. If you go to our website, I'll share the link at the end of my prepared remarks, and you'll see that we actually document each of these projects in much more detail. We describe the partnerships we have with universities, with research institutes, and with other entities that we are partnering with inside or outside of government as well. Now, I know that there's a few colleagues on this call or few or folks and guests in the audience who have a technical orientation, and they appreciate sort of the cases which I've now shared with you, sort of some of the examples, but they're interested in the technology behind what we do. And so that's one of the things that when we hired high potential data scientists from universities and from research institutes and from the private sector to start our digital accelerator, they joined us because they wanted to come work for the government, because they wanted to have meaningful problems to solve. And that's certainly something you get the opportunity to do in the government. But they also came because they wanted to be able to have the right sort of tooling to be able to solve those problems with. And as we know that in the field of artificial intelligence, these breakthroughs are happening on a daily basis, these conceptual breakthroughs, this groundbreaking research on a new basis. Every day you see some new algorithm or some new optimization technique or some new architecture. So that knowledge is now available to data scientists, all data scientists, in many of these packages which I've listed. So this slide is actually giving you an idea of not all, but most of the major tools which we use in our digital accelerator lab in Natural Resources Canada. So we use most of the mainstream machine learning packages. We use the most frequently used data science packages, deep learning packages, reinforcement learning packages, most of the major programming languages and integrated development environments. You'll notice that we do have subscriptions on all of the major cloud vendors out there. So whether it's Microsoft Azure or Google Cloud Platform or Amazon Web Services. And so, we do a lot of our testing, we do a lot of our trials on those cloud environments where you can scale them elastically and you don't have to be bound by how much silicon you actually have in your lab to be able to run some heavy workloads through. But aside from that, we also really focus on ensuring that once we build the prototypes, once we build the pilots, once we build the proofs of concept, that they can be scaled elegantly as well. Once the project is done and the deliverables are handed to the proponents, we want to make sure that they can get something that has all the dependencies and has all the requirements and has all of the components which are needed to then scale that application into production are available to them. So you can see this on the right side of the slide, how we have this approach of containerization, where we actually do a lot of testing on the code level, but then when everything is ready to be shipped, then we can containerize it, give it to the proponent, give it to the person who's our sort of partner who's asking for that project, and then they can take it and then decide how they want to actually deploy that in the cloud or deploy that in-house. Now, in some cases, or in quite a few cases, I should say, we do have situations where we cannot actually use publicly available cloud providers, even if they are protected B, because there could be national security implications to the certain data sets, or there could be ownership concerns around IP. There could be other concerns around not the data sets themselves, but the models which are learned from a security or a confidentiality or a cybersecurity perspective. So in that case, we have our own high performance computing lab that we have set up in Natural Resources Canada. And so we've acquired some high performance compute devices which are specifically calibrated and optimized and geared towards doing data science workloads and some heavy duty number crunching, which is related to training of machine learning models and deep learning models. So we have these Lambda blades and Lambda servers in which we have multiple GPU based chipsets, which allow us to do a lot of the jobs in-house that we either do not want to or are not ready to put on the cloud. So this sort of gives you a high level idea of everything that we have done so far to get our digital accelerator to where we are. I'll just take a few minutes now to reflect back and talk about some of the lessons we've learned, because we've now been doing this for about 18 months, and everything from the culture perspective to the talent perspective to the partnership perspective to the governance perspective, we've had now the chance to sort of look back and reflect and think about how things went and what could be done differently going forward. And really our forward plans are now being informed by some of the reflections that we've been able to critically self-appraise ourselves. So the first thing is really understanding the importance of partners. A lot of times in public sector organizations, there is the notion to look at external vendors truly as that, as suppliers, where the relationship is, it's not even a relationship, it's basically a transactional interaction, where essentially everything is software for dollars, right? And when you think about the way that we've approached partnerships, it's truly been from a relational lens. I mean, of course, if there's software involved, then that organization gets paid for the software. But when you think about our partnership with an organization like Microsoft, for example, it's not just that Microsoft makes software that we want to be able to access, or Google does the same. And we have a partnership, also very happy partnership with Google. It's that they also have some very, very smart people that work there. They also have a commitment to solving the same types of problems that we want to solve, whether it's sustainability, whether it's sort of greening supply chains, whether it's net zero, whether it's carbon decarbonization, deep decarbonization. So, just looking at them as vendors who can sell you bits for dollars, there needs to be a better way to really co-create win-win opportunities where there are responsible and mutually beneficial symbiotic ways to partner with them. So we appreciate that, and we've had to really calibrate our sort of mind frame of how it is that one can go about building these types of win-win partnerships, where in many cases it's the first for government, and in many cases it's the first for outside organizations, right? So really coming up with these new models of partnerships and designing them and then operationalizing them, I think that is something that I would encourage everybody who's setting up a digital accelerator or running one already to really give foresight to. It's something that requires you to understand what the motivations and the incentives on the other side are. It requires them to understand what your incentives and goals are, and really find those mutually beneficial sweet spots in the middle where you can have a partnership, where you can have responsible resource pooling, knowledge sharing, exchange of resources, exchange sharing of ideas, and really having the proper governance built around it to ensure that we abide by all of the requirements of operating within a government organization are properly abided by. The other thing is, as I mentioned a few times, is focusing on value co-creation. This is extremely, extremely important, because what we did not want to have happen was to hire a few data scientists and then grow that complement of data scientists. So the number of projects that we can deliver goes up over time. But collectively, if we look at the department as a whole, the digital quotient and the digital acumen remains stuck. In fact, it starts to degrade and it starts to go backwards, because obviously the rate of change outside where the technology is really being developed is accelerating on a continuous basis. So if we're not keeping up with it, we're not going to be able to catch it. And in fact, we're going to start falling further behind. So creating opportunities to have safe, inclusive, welcoming spaces where people, irrespective of their current level of technology understanding or their current job, can come and ask questions. So lunch and learn sessions, ask an expert sessions, ask me anything sessions, really facilitating a community of practice within the department, but linking up with broader communities of practice, such as, ISACA, for instance, but also within the federal family. I think that's something that has to be done with intention and has to be done with purpose. Otherwise, it gets completely sort of disconnected and unconnected, and really we lose the advantages of scale. So in our digital accelerator, we've really focused on this notion of value co-creation, where not only are our projects things where we make sure that the data scientists and the digital solution architects work closely with the proponents, whether they're from science and or from policy, but we also then do so in a way where there's opportunities for colleagues who don't interact with us on a project basis in our department to be able to really benefit from some of the knowledge that our experts are bringing to the table, but also then have our experts learn about the core business, if you will, of our department as well. The third thing, which is very, very important and gets overlooked quite often, is tying investments to objectives. And so being able to answer the so what question. And what do I mean by this? Very often when you work with artificial intelligence, data science, by their very nature, these are experimental domains. These are exploratory domains, right? You can think about new algorithms that are getting released, new packages that are getting released, some new data sets becomes available to you, some new problem gets dropped on you. So there's always this, the very essence of science is experimental and exploratory, as you think about the science part of data science. So it's very easy to sort of go down that road, which to an extent is great, but then to sort of become untethered, even if it's unconsciously or unintentionally, from the so what question or the why question. So this is something that we do in our accelerator right from the project intake process, is to tie the work that we're going to do to contribute to the advancement of a project to our department's mission and mandate, to our organization's strategic priorities and plans. And if you don't do that with foresight, if you don't do that purposefully, then what ends up happening sometimes is that you have this great sort of experimental lab, you have this great sort of technology launch pad where you're exploring all types of new technologies, but they're really not problems. They may be problems in a technical solutions in a technical sense, but they're not solutions in a organizational sense, because you're not really mapping them to problems that you need to solve in order to advance the mission of your department. So that's something I want to mention as well. There's a lot of work we're doing right now, if you want to partner with us in our department right now, on building a framework to measure the value of data and the value of digital solutions. We all hear intuitively people say data is the new oil. Data is the new plutonium. But it's very interesting. You know, I've had leaders in my organization make the comment to me that we know what the worth of our buildings are. We know what the worth of our fleet of vehicles is. We know what the worth of some of our physical equipment is. But can we actually decisively say what the worth of a data set is or a digital solution is? I mean, in a non-anecdotal sense, but in a slightly more precise and a more rigorously defensible sense. So that is something that, you know, a lot of people think colloquially, we all sort of have an intuitive handle on what we mean when we say the value of data or the value of a digital solution, but to have it so it's uniform and it's comparable and it's standardizable and it can be harmonized, so you can actually make decisions around prioritization about data sets, about other intangible artifacts in your enterprise like software packages. That is something that we're actually working on right now in partnership with the University of Toronto and other federal departments. So if you're interested, Agriculture Canada, for instance, if you're interested in sort of working with us on that, happy to entertain any interest that you may wish to share. Knowledge sharing, I'm not going to spend too much time on this. This is very self-evident and self-apparent. I talked about this before, but really not just to have an opportunity where our data scientists are only available to colleagues who do projects with them, but also make our data scientists available to our rest of the department through these safe, welcoming, not judgment-free, inclusive spaces where we can have sessions on knowledge sharing. We can have communities of practice. Some are more functional, some are more technical, and really encourage that culture of knowledge sharing about data science, about AI in a very practical and a very, very mutually beneficial sense. And last but not the least, this is very, very important too from my perspective, which is adopt a multi-speed enterprise architecture mind frame. Encourage experimentation and exploration. So what do I mean by that? Very often in public sector IT, we, for good reason, take a very linear, a very continuous, and a very symmetrical view of information systems. And what that means is that because we have HR systems, we have financial systems, we have systems that are used for cybersecurity. I mean, certainly with those systems, there are very, very rigorous and rigid oversights attached to it, rightly so. There are mechanisms for compliance management. There are mechanisms for risk mitigation, uncertainty avoidance. I mean, that is all certainly very, very relevant. But scientific computing in many cases is actually a bit different, quite different, because in scientific computing, you have to be able to fail early, fail fast, experiment, explore, try things, use approaches like lean thinking, use approaches like agile, use approaches like lean startup, design thinking. So sometimes when you're in a situation where you are bringing the mind frame of managing enterprise IT systems, such as the business systems of your enterprise around finance, around HR, around logistics, around procurement, and bringing that in, that sort of same approach to managing computing to a scientific computing environment, then you might unnecessarily stifle or constrain the degree of autonomy or the latitude that is needed within a scientific computing frame to be able to make these meaningful advances. And so there, what we've found to be very useful is through a great partnership between myself and our Chief Information Officer and our Chief Digital Officer at NRCan, is to really adopt a multi-speed view of the enterprise, where yes, you have your core business applications, as I've described, that are managed and governed and sort of run in a certain way. But at the same time, then you also have these other scientific computing systems, which are using the latest and greatest breakthroughs and advances in artificial intelligence and data science and machine learning in ways that are operating, shall we say, at a different speed, where failure is certainly tolerated, if not encouraged, because that is really where new innovations and creativity spurs from. So with that, I'd like to now just share the contact information for our accelerator. If you found anything that I've mentioned interesting, if you're doing something similar, if you'd like to partner with us, if you're looking to start an accelerator or you already have an accelerator and you'd like to just maybe exchange notes and swap ideas with us, very, very open to partnerships, very open to collaborating with everybody. And with that, Bob, I'd like to close my presentation and turn it back to you for questions. Thank you, Bob, for the opportunity.
Boy, you covered a lot of ground. That was a great presentation. Thank you very much. Okay, we got questions, so I'll just start going at them very quickly here. Can you elaborate on the AI used in the forest inventory monitoring? Was it used by all stakeholders?
That's a really good question. So as I mentioned with the forest inventory, the AI analysis is one contributor to the overall information system. So our colleagues in the Forest Service have a very comprehensive approach to this, where they have an information system that they use to track our forest inventory. But as you can imagine, there's always opportunities to introduce some new insights or some new data sets or some new sort of inferences into an existing system, thereby elevating the quality of the insights you can derive from it. So the type of AI which we're using, for instance, as I described, was using satellite imagery to essentially look at the forest cover and try to make understandings of what types of trees are growing where and what the density of the forest looks like and what the scope and the span of the forest looks like. But as I mentioned, that is, it's not just that the information system around forest inventory is purely an AI system, but now AI as a new input into that system is helping us to have to derive richer insights. Great question. Thank you.
Okay, the next question is, are you addressing AI and cybersecurity at all?
Yes, we do, but not so much from not so much at a production level yet. That's a great question, and that brings me back to the last comment which I made. When it comes to cybersecurity related to the energy grid, I mean, there are proper, well-established providers of cybersecurity systems working closely with our intelligence partners who have quite a bit of the acquired as well as own developed software. But certainly, you know, using techniques to do different types of cybersecurity testing or doing packet inspections or doing anomaly detection or trying to do simulations on adversarial threat scenarios. So those are things which we are experimenting with, but those are certainly not things that I would claim are production ready. For the production ready part of it, there are existing solutions which our department and stakeholders in the value of the energy grid actually use very successfully.
Thank you. Next question. Does NRCan retain an interest in the resulting intellectual properties?
That is actually a great question. Thank you for that. You know, and when it comes to this, not having a proper framework or a full understanding of how IP works with these digital intangible assets, I suspect, this is purely my personal opinion, is what sort of precluded a lot of the types of partnerships that we have now started to benefit from forming in the past. Now, very good question. When we, as I mentioned before, some of the software vendors who I mentioned, who NRCan has these partnerships with, we had to really go through a very rigorous IP impact assessment process in our department of what those partnerships could mean and could possibly do. At the same time, go through proper legal review. And of course, this is happening on the other side of the table as well. Those organizations also have their own IP people and people. So there was a very intense process of negotiation where we ended up arriving at a situation that was mutually beneficial. One thing you can certainly keep in mind is, you know, the government of Canada, just out of our commitment to transparency and public accountability and openness, we do release a lot of our data sets in the public open domain. You can go to Open Data and access all types of data sets that the government of Canada willfully and voluntarily puts out there. So now, if those organizations are already using those data sets to do some things, but now we can actually have a mutually beneficial relationship in those interactions. That's really what we've done. But great question. IP, yes, we do retain IP interest, and negotiating that really took quite a few months of going back and forth. Thank you.
Okay. We'll just take a look at the next question is, do you map and monitor pollution by companies or societies? Do you promote projects that encourage recycling and environmental protections? It's sort of a double whammy question, but
Yeah,
do you monitor? Go ahead.
Yeah, no, absolutely, Bob. Thank you, if I may. And you know, this actually really helps me to explain kind of what we do in the Accelerator. So in NRCan, in our core sectors, they have many highly efficacious and very impactful programs on promoting the use of clean energy, energy efficiency, avoiding energy waste, etc. Now, those types of programs are run out of our sectors. Our sectors manage those programs. When they have need for using AI techniques or data science techniques to maybe analyze some data set or to do some simulations or to do some forecasting or build some estimates, then their policy leaders and science experts come to our data scientists and we help them do those projects. So the answer is yes, that those programs do exist. And indeed, in many cases, our team has made meaningful contributions from a data analysis, modeling, forecasting to the improvement and operation of those programs. Yes.
Okay, great. Next question. Who are your partners for the electrical vehicle load prediction project?
Yes, so we have a number of partners. I would request the colleague who's asked the question to look on our website. It's all listed. It's a long list. But to give you an idea, we have partnered up with some of the Pan-Canadian AI Strategy Institute. So you know that the government of Canada had funded through CFAR three main Pan-Canadian AI research institutes throughout Canada. So Mila in Quebec and Vector in Toronto and Amy in Edmonton. So those we're working with those partners. We're certainly working with Amy, also with Microsoft. That's one of our keystone partners on that project. And there are also some academic partners which are listed on our project website, where each project is described in detail.
Great. And we got one last question. You have described innovative projects that focus on NRCan, such as energy, mining, forestry, including electrical vehicles. Oh, we've already talked about the cybersecurity project question with respect to protecting the grid and the like. And also, do you look into cyber protection for example, autonomous vehicles?
To the extent that that would extend to a scenario that is relevant for energy, forestry, and mining, sure. So if you think about autonomous underground vehicles that would be going into mines to do some kind of work there, those would certainly be of interest to us, or autonomous vehicles that are being used in a forestry or some other scenario that is of relevance to NRCan, absolutely. But there are other departments as well. For instance, I know colleagues at Transport Canada look into that quite closely. NRC looks into that. So we focus really on energy, forestry, and mining sort of in a direct sense. And there's plenty. It's a target-rich environment for us as it is, Bob, as you can imagine, with areas to apply AI. So we try to keep it as focused and targeted as we possibly can.
Fully understand. Well, thank you ever so much, Vik, for coming out to speak to us. And I'm sure the client, basically the presentation will be posted and you'll be made available, the coordinates, as well as a recording. Anyways, there's a three-phase program. I'll talk about that in a moment in the concluding results. But anyways, thank you very much, Vik. I'm just going to go now into, let's see now, share screen, into the final presentation. And ladies and gentlemen, the conference is over. Thank you ever so much for your attendance. It's been a big success. We've had up to 700 people registered. It's great. Next year, what we're doing is, next year we're planning 14 to 16 June 2022. Put it in your calendars. It's going to be probably a hybrid conference. I'll talk about that in a moment. But no conference is possible without a committee that's working behind the scenes to make things work. And essentially, we had more than 700 attendees coming in, more than 450 of public servants. Copies of the presentation, the team is now working on posting them into the website. They're going to be temporarily on CVent, and they're going to be placed on digitaltransform.ca/2021. That's going to be our standard for all the previous next years. It'll just be 2022 and so on. Copies of recordings will advise you where they're going. Temporarily, they're going to be in the CVent software, and if you've registered, you'll have access to it. But we're going to make it globally available as an open educational resource. University of Ottawa, the librarians right now are figuring out how to do it because they're not used to recordings and the like going into open educational resources. We're going to publish the presentations and the recordings in an open source journal. It's a proceedings. And then we'll basically make them available globally. They'll be accessible and searchable. They're going to be open data for the like. And like I said, no conference goes. All the people that are doing all this work, it's the committee. Many thanks to my deputy, Jean-Luc Lemieux. He's the director of conferences and the secretary designate for ISACA, Ottawa Valley chapter. He's a senior consultant of Samson Associates and president of Jean-Luc Lemieux as a certified public accountant. He's volunteered and he manages the technology program. He's been talking with all the speakers, making sure that everything goes smoothly. And to be quite honest with you, this is the first conference where everything has gone pretty smoothly. Okay, the odd hiccup, we've been able to handle it. So thank you very much, Jean-Luc Lemieux. We wouldn't have been able to do it without you. And then, of course, unfortunately, we had Zenos Khan from the Association of Enterprise Architects. All of a sudden, he passed away suddenly, well before his time in May 2021. He was a gifted and warm-hearted man dedicated to his family and his colleagues at Gilder, Gingras and Associates, where he was vice president consulting, and at ESDC, the Employment and Social Development Canada, where he's working on the cloud reference architecture. He will be sorely missed as an individual. It was a real tragedy when that happened, so I just want to make sure that he was acknowledged for the work he did in helping set up the conference. Then there's Will, the conference website administrator from Isaka, Ottawa Valley. He's a member of the Office of the Auditor General of Canada, and he's been doing IT performance audits and he works for Joanna. He's been basically maintaining the web presence and making sure that all the communications and everything in the back end goes well in terms of posting all the material that's been provided. And there's been a tremendous amount. Thank you very much, Will. Then there is Jean Lapierre, another government employee. He's working for the Association of Enterprise Architects. He's director for government advocacy, and he's been responsible for many of the speakers that have turned up, and also for getting the word out on GC Collab. Basically, he's working now at ESDC. He's been working in various departments before that, but he was invaluable in terms of getting the word out in the street and getting the public servants making them aware that the conference was going to exist. We had more than 450 public servants attend the conference. Then there's Isaka. You can't go anywhere without money. And Jenny Z, who works for NAV Canada, she has been keeping us honest and making sure that all the bills are being paid, and also at the same time that we're respecting all the audit rules for the organization. She's a treasurer for the local chapter of the Isaka Ottawa Valley, and she's done a great job. Now, look, if you want to join any of these associations, I really recommend them too. That we give, everywhere there's monthly seminars of interest. I know if you get a professional certification, you need the continuing professional education credits. It's a good place to get them. Then, you've got the guy who's been boring with you. One of the advantages of being sort of semi-retired, but working harder than I ever have, is that you can pick and choose. I belong to multiple organizations, and one of my sole motivations is to bring everybody together, including the academic community. Spent 40 years, 30 years in government, 10 years consulting the government, and then I decided to take a PhD to make sure it wasn't too stale. I'm working actively with international standards and do some consulting to keep the fiscal woes at bay. But basically, I'm enjoying a third career in academia, and very much enjoying myself with a very dynamic environment that Liam and Tim have painted of the University of Ottawa. It's really going places. It's a wonderful place to be at this point in time. So for next year, we've already started planning. We're looking at having a hybrid conference, okay, in the University of Ottawa. There we're going to have plenaries, specialist streams. We're looking at also including peer-reviewed streams for the academia and for people that want to have their papers published. It'll be part of the proceedings. And we're looking for more partners. So if you want to volunteer, you want to partner, you want to sponsor, send me an email. I'll be more than glad to bring you on board. And now, this is it. Thank you very much for attending the conference. It's been an absolute pleasure. And what I hope is that in the future, our paths will all cross. And we're going to go out of presentation mode here. We'll stop screen sharing. That basically what we can do is we can meet up again. I think the biggest lesson learned from this is we all have to work together. We all have to collaborate. Digital transformation is not going to come alone. And I think we all realize that government is probably the most complex organization on the face of this earth, and we all have challenges. In sharing with the professional associations, with academia, the private sector, and the public sector, we can make it happen for the betterment of society. Thank you very much. And this is the end of Digital Transformation in Government Conference 2021. Thank you all.